We've all been told since grade school that the angles of a triangle add up to exactly 180 degrees.
Undeniable or just convenient?
It's literally in every textbook.
Check this out.
It feels like a law of nature, right? But for centuries, the mathematicians were hunted by a nagging question. Can we actually prove it without just assuming Euclid's fifth postulate is true?
Enter the Saccheri-Legendre Theorem. It tells us that in neutral geometry, where we don't assume the parallel postulate, the sum of the angles of a triangle is less than or equal to 180 degrees.
The theorem is named after Giovanni Saccheri and Adrian Marie Legendre. Their goal was to prove that the sum must be 180 degrees, but what they actually managed to prove was that it can never exceed 180 degrees.
How do you prove something so broad? You can actually imagine this in real life. Consider a saddle-shaped surface like a Pringle chip, a hyperbolic paraboloid. If we place 3 points A, B, and C on this surface and connect them using the shortest paths along the surface, we form a triangle. Because the surface has negative curvature, these short paths diverge more than they would on a flat plane. As a result, the angles at A, B, and C are smaller than in Euclidean geometry, and their sum is less than 180 degrees. However, this model is only an approximation of true hyperbolic geometry, so this behavior is most accurate for small triangles.
This shows that when space is curved, even in everyday structures, geometry changes. On flat surfaces, triangles always add up to 180 degrees. But on curved surfaces, like that group, the angle sum can change.
So, the Saccheri-Legendre Theorem tells us something powerful. 180 degrees is the maximum possible sum of angles in a triangle.
You can reach it or go below it, but you can never go beyond it.
Geometry, keeping triangles humble since 1733.